Hello eye tracking community, my name is Michael, and in this tutorial we will talk about how we can check the quality of the recorded eye tracking data. This tutorial is a part of our series, the 3 main steps of an eye tracking analysis. If you want to see all the videos of this series, please have a look at this playlist. On the screen, we can see Blickshift Analytics after the import of the eye tracking data. First, I will have a look at the eye tracking data. So let's get an overview about the experiment. I go to the data source, make a right click, say Visualizations, Line Graph. I go to the line graph, make a right click, say Visualizations, Film Strip. Here we can see an exported video from the recording. We recorded this eye tracking data with a pupil core eye tracker. We've used pupil capture for the recording and pupil player for processing the data. In pupil player, we've used the fixation detection plugin there and also the blink detection. So imagine the following situation. Someone recorded the data for you and your job is now to analyze this data. In data science, there is this famous sentence saying garbage in, garbage out, which means that if the data quality at the beginning is bad, so will be the results. And in this tutorial, I will show you how you can quickly check the data quality of the recorded eye tracking data with Blickshift Analytics. In this experiment, the participant had to craft a paper plane. So we have the manual and the participant followed the different steps in the manual. To analyze now the eye tracking data quality, I go to the eye tracking data source here, make a right click, say Analysis, and then AOI Editor. I zoom out and now I draw an area of interest which covers the whole stimulus. So the whole scene video through the whole recording. I make a right click on the AOI editor and then I choose the gaze statistics component. This gaze statistics component gives me now up to 20 different metrics for an area of interest, in this case for AOI 1. I change here from minutes and seconds format to seconds format. For the data quality check now, we have a look here at the fixation count. So in the pre-processing step, 410 fixations have been detected during 83 seconds where eyes or where a gaze vector has been detected, which goes to the area of interest number 1 with fixations. An eye tracker records gaze points, not fixations. That's important. Gaze points is the way how an eye tracker sees the eyes. However, this is not the way how a human being is visually perceiving the environment. We perform fixations. And the discussion what the fixation is so old like eye tracking is. If you want to learn more about gaze points, fixations and saccades, please have a look at this tutorial. So back to our data set. We have 83 seconds total gaze duration on the whole stimulus and 410 fixations, which means that we have an average fixation duration of roughly 200 milliseconds, which is quite okay because a fixation usually takes between 150 and 250 milliseconds. So I could think now everything is great. I will continue now with the analysis. Since the goal of this tutorial is not to go quickly to the analysis, but to double check the data quality, let's continue here. What I find interesting is that we have 83 seconds total gaze duration and these 70 seconds where the eyes haven't been detected. So what is going on here? I mean, in total, we have 153 seconds in recording and 70 seconds, so 45% of that, no eyes have been detected, or at least no fixations have been detected. That's very unusual. So let's dive now into the data and see what happened there. So I go to the previous visualizations, and here I add another line graph visualization. I deactivate the time axis here because we have it here on the left side. And then I visualize what is called confidence in this case. So the eye tracker software gives us a metric which indicates the quality of the eye detection itself. And they call it confidence. So please check if your eye tracker also provides such a value for you. So I choose here the confidence. Most times it's here around 1 or at least above 0.8, but also we have these lower values here on the left side. The fixation detection also calculates such a confidence value. And I can find it when I enter here conf and choose confidence fixation. And here we can immediately see what is going on. So when I make this window a bit larger and we go through the experiment, you can see what is going on. In case of a pupil player export, we have two information in the video itself. The green circle is a gaze point. And whenever a fixation has been detected, the pupil player export shows us a yellow circle. And you can very well understand how this is working if we look at this section here. So here, when we follow now the current moment in time, so this red line here, we have some fixations. And for whatever reason, here fixations are missing. So we only have here the green circles, only gaze points, but no fixations. And there are many of these sections in the data where this happens. And this is the reason why we have here this high number of not correctly detected eyes. There can be many reasons why you can have something like this in your data set. One reason could be a bad calibration at the beginning. So please check that, recalibrate, try it again. Another reason could be the setup of the eye tracker on the head. So perhaps it moved during the experiment, so the calibration is not correct anymore. Another reason could be that you have glance lights on the corneal. So for example, from lights in the room, which leads to a bad eye detection. And finally, there could be some physiological reasons of the participants because of the eyes themselves. Now, what can you do in such a case? If I would have such a data set, since I cannot change the recording itself anymore, I would try different parameters of the fixation detection component. So to play a bit with the parameters and to visualize the results afterwards to see if this could have an effect on the data quality. Also, what I can do is to detect the parts in the experiments with a good data quality and to focus my analysis on these parts and to remove the parts with the bad quality from the data set. How you can select different parts in your experiment based on different metrics, you can learn in this tutorial. Finally, but this is the worst solution, is to remove this participant from the participants which I want to analyze. From my experience, usually around 10% have to be removed from your experimental data for getting good results during your analysis. So which means that if you're planning with roughly 30 participants which you want to analyze, you should work with, I don't know, around 35 participants or so. My goal of this tutorial was to show you the importance of a data quality check, because sometimes data quality looks very well, but if you dive into the data, then you find out, okay, there are some parts with a bad data quality which could really influence my results afterwards. And by diving into the data and by detecting these sections, you can avoid garbage in, garbage out, because at the beginning, right from the beginning, you have a very good data quality, and so your results will be also very, very great. Thank you very much for watching this tutorial. If you like this tutorial, please push the like button, subscribe to our channel and activate the bell so that you'll never miss a new tutorial on this channel. I'm looking forward to see you in the next video.